have book assignments. Every assignment in this unit is a worksheet. Now, I'm not going to collect your books because you may want them as we study for our final / AP test. Okay? You might need that to refer to. But you won't have a book assignment anymore. Okay. All right, so we are going to be working with motion, and specifically it's just going to be linear motion, which means we're going to go only one way, okay? We have a particle that's moving back and forth on a line, so you can think of, right now we'll talk a lot about left to right, okay? Tomorrow we're going to talk about like the up-down. Okay, and really when we see up-down motion, it's really just dropping an object. Okay, so a lot of down. Okay, but right now we're going to talk about moving left to right. Okay, so Mrs. Holman paces back and forth. Okay, that's linear motion. Okay, I'm just walking back and forth on a line. Okay, moving left to right. Okay. I know this is kind of strange, but S is going to be, S is going to notate our position, okay? So the S axis is what Mrs. Homan is pacing back and forth on, okay? S notates position. Make that note somehow. T denotes time, okay? I have up there T axis. While yes, we are going to be working with motion that's only back and forth, we are going to graph it on a position time graph. Those of you who have had physics, or in physics, or even some physical science, you've talked about position time graphs, velocity time graphs. It's all coming for full circle. We're going to relate that to calculus. Okay? This actually gets easier when you know the calculus behind it. Okay? Okay. So first of all, let's talk about these things. On your worksheet, when I say, so this, the first one, initially means what is 0? T. When I say initially, time is 0. Okay? At the origin, so if we have a position time graph, okay, time, position, what does the origin represent? Our distance is 0. We haven't moved in. Okay. Okay, so velocity is a measure of the amount of distance traveled over a period of time. I just described to you a rate of change. So how does velocity relate to position? It is the derivative. Okay? So that is the first thing we are going to talk about. Okay? Instantaneous velocity is a rate. Okay? It is a rate of the particle's position as it changes with time. Okay? So what you guys figured out in your homework is that means that the velocity, the instantaneous velocity, is just the derivative of position. Now, those of you who are in physics, tell me something about velocity. Velocity gives us a rate, but it also gives us a direction. Okay, velocity can be positive, velocity can be negative. Okay, so if I ever want to know the speed of an object, what do I have to do with velocity? We have to do the absolute value. Okay. Okay. Now, back to that pink worksheet that you have. What would it mean if v of t is 0? Okay, so if there's no speed, it ain't moving. Okay, thank you, Trevor. Okay, so if our velocity is 0, the particle's not moving. Okay, that's something to watch out for. It's going to be important. How about if our velocity is positive? What is that going to mean about the direction of the particle? It's going to go to the right. Okay, positive velocity means we are going to be moving right. When we think of a number line, we get more positive to the right. Okay. Therefore, negative velocity means we are moving left. Okay. A lot of what we're going to do today is analyze what's happening to a particle. When is it stopped? When is it moving right? When is it moving left? When is it to the right of the origin? When is it to the left of the origin? Okay, those are things that we need to be able to pick out. Okay. Now, we're going to do this a number of different ways. You need to be able to do this 3 ways. You need to be able to look at a table of values and determine what's happening. You need to be able to look at a graph and determine what's happening. You need to be able to look at an equation and determine what's happening. Okay? Probably the simplest is an equation. Okay? You guys are really good at algebra. Okay? And we'll get to an example like that later, but let's just look at a graph. Okay? Here I have the graph of our position, S of t, is t cubed minus 6t squared. Okay? And I have it graphed for you. So I just want you to look at that graph for a moment. This is the position versus time graph. What's happening at 0 and 6?
Different direction.
At t equals 0 and 6, our position is 0. Therefore, our particle is at the origin. Okay? So I want you to think of this. If I'm pacing back and forth on a line, when S of t is 0, we're at that 0 mark. Okay? So if I start right here, and I pace to the left, and then I pace to the right, okay, I'm pacing, sorry, I pace to the right, I pace to the left, here I'm at the origin, and I turn around, here I'm at the origin again. Okay, so we have to think of like number line origin. Okay? What would it mean if, like from 0 to 6, our position is negative? What does that mean? We're to the left of the origin. So from 0 to 6, we are to the left. And from, we'll just say 6 to 8, we are to the right of the origin. Okay. Now, I'm going to go to the velocity graph and we're going to look at some things there, but then come back to the position graph and relate the two graphs together. Okay, I did have you look at a derivative graph for a reason, okay, because we're going to be doing some fun things with that. Okay, so let's look at the velocity graph. If position is t cubed minus 6t squared, CJ, what's our velocity graph? Our equation.
It will be 3t squared minus 12t.
Good. It's the derivative. Velocity is just the derivative of position. Yes. So if we think about, if we have our function s, when we take the derivative, it's ds dt, right? So change in position over change in time. Isn't that what you just described the velocity to me? Does that make sense? Okay. Good question. Good question. Here's our velocity graph. Okay, so now let's look at the zeros of the velocity graph. What's happening at t equals 0 and t equals 4?
The object is our left or our like switches directions.
Okay. Okay. Our particle is at rest. Now, Jackson said, or switching directions. In order for an object to switch directions, okay, if I'm pacing back and forth, I have to stop my motion to the left before I can go to the right. Correct? So anytime a particle switches direction, it has to come to a rest before it can go back. Okay? So, since our velocity is negative from 0 to 4, what's happening? Okay, moving left. And since our velocity is positive from 4 to 8, I did the 8 last time, so I'll just keep it consistent, then our particle is moving right. Okay. Now let's see if I can do this here. Okay, I can do it here. Okay, so now I have both of these up here, and I know they're small, and I apologize, but we'll make do. All right. Notice how we determined that since our velocity was below the x-axis, negative, it's moving to the left. What can we pick out on the position graph? What's happening from 0 to 4? Decreasing. So when our position is decreasing, we have negative velocity, meaning we're moving left. Okay? From 4 to 8. From 4 to 8, our position is increasing, which means we have positive velocity. We are moving right. Okay? What I love about our motion unit is that we encompass darn near everything we've learned in calculus and we put it together. Okay? It's been a while since we've read derivative graphs, okay? But it's important for us to go back and remember those things. All right? If velocity is the derivative of position, then we can look at a position graph and know what's happening in velocity, okay, based on the slopes. Okay. Okay. Now, let me get rid of this double page here. Okay. Let's think about what happens with speed. You told me that we just need the absolute value of velocity for speed, right? What does an absolute value do? Okay, it takes everything and puts it positive. So this negative right here has to go positive. So you know what that looks like? Okay, focus on that 0 to 4. You ready? That's what happens. This is the speed. So if we look at our speed, okay, our speed is increasing from 0 to 2. Our speed is decreasing from 2 to 4. And our speed is increasing from 4 to 8. So I would describe this as we're speeding up, slowing down, speeding up. Would you agree? Okay. Do you think that has anything to do with concavity?
Well, it has to.
It has to? What does it have to?
Well, everything comes full circle. Since we're doing everything we learned this year.
Okay. I'm going to come back to this guy right here. We said 0 to 2, we're speeding up. 2 to 4, we were slowing down. 4 to 8, we're speeding up. Now, I don't know about you, but I only see one point of inflection up there. But I just gave you 3 intervals. Okay? So while it doesn't relate directly to what the concavity is, it has something to do with it. Okay, it's a factor. So let's first talk about acceleration. What does acceleration mean?
It's the rate at which velocity will change.
Okay. Rate of change of velocity. Exactly what CJ said right there. Velocity is the rate of change, acceleration is the rate of change of velocity. So essentially we're working with the rate of change on the rate of change, aka the second derivative, okay? You already have this written down. Okay, so we'll add to our little chart here. The second derivative of position, which is the first derivative of velocity, is what we call acceleration. Do you talk about this in physics? That relationship between the three? But you don't actually take derivatives, correct?
No.
Okay.
That's an insane amount of algebra.
Yeah. Are you excited?
Well, I did physics last year, so it
Oh.
won't help me anymore. But
Okay. Now, when we talk about speeding up and slowing down, we have to take into account velocity and acceleration working together. Okay? Describe to me speeding up. You're going faster. Okay? Now, if I'm running in a straight line, you know, I take off, right? I take off and I'm running faster, but then before I come to a stop, I have to slow down, right? My motion was all in the same direction, what I just did there, correct? But I sped up and slowed down. So what does it take? What has to work together for our particle to speed up?
Acceleration has to be
Okay, if our velocity and acceleration are both positive, we're speeding up, right? What else? Okay, doesn't matter if they're positive versus negative. It matters that they're the same sign, okay? So when velocity and acceleration are working together in the same direction, then the particle is speeding up. Think of hitting the gas pedal on your car. If you're at a stop, you hit the gas pedal, you're moving forward, and your acceleration is positive because you're gonna go faster, right? Now, think about this. You're driving along 370, you get to the stoplight, you have to put on your brake. Now, you are still moving forward, but you are deaccelerating, or you're decelerating. Sorry, put an extra syllable in there, okay? But you're decelerating. So I'm going forward, but I'm decelerating, which means we are slowing down. So if your velocity and acceleration have different sign values, like what I just described, we have positive velocity but negative acceleration, then we're slowing down. Okay. So it's not as simple as just like, oh, concave up, that tells me about our speeding up. No, is our position concave up and our velocity positive, that means we're speeding up, okay? Negative acceleration and negative velocity means we're speeding up. So, over here, we had our velocity graph. Okay, let's talk about our acceleration. If our velocity is 3t squared minus 12t, Eli, acceleration would be?
Positive.
Let's just talk about the equation, right? We know that the derivative of velocity is acceleration. Velocity is 3t squared minus 12t. So what's the derivative?
16 minus 12.
Okay, nice and simple, right? So here is our our acceleration graph. Okay. Notice how we have negative acceleration from 0 to 2, and we have positive acceleration from 2 to 8, right? If we look at this graph right here, okay, so our point of inflection is at 2. So since we are concave down and decreasing, decreasing means, so at 0 to 2. Okay, decreasing means our velocity, our derivative is negative, right? Do you agree that this is concave down? From 0 to 2, we are concave down, which means our acceleration is negative. So from 0 to 2, this particle is speeding up, because our velocity and acceleration are both negative. Let's work with some equations. Okay? We feel more comfortable when we're working with equations. It's just a fact. So let's do some of this full circle with this guy right here. Go ahead and write it down. Okay? So when I ask you to analyze, okay, I'm worried about moving right, moving left, stopped, speeding up, slowing down. Okay? So we basically need to analyze the velocity function and the acceleration function to make those evaluations. Okay? I would love to determine where this is at the origin, to the left, to the right, but I don't think that's going to happen because that's not a cubic function that we're going to set equal to 0 and solve with ease, so we're not going to do that. Okay, let's just go straight to velocity. Okay, so our velocity function, we're just going to take the derivative. 6t squared minus 42t plus 60. Now, to do anything with figuring out where this is stopped, moving left, moving right, we need to know where it stopped, because that breaks up any change of direction. Okay? So, it stopped when our velocity is 0. Okay. Can I divide that right side by 6? Oh, look at that. So much nicer, isn't it? So t, negative 2, negative
Yeah.
5? Okay. going to make a number line. Okay, this is my velocity number line. And do you notice how I labeled it velocity? We're going to make another one with acceleration. Okay, so first of all, we really only care about what happens from 0 on, because time is a negative. Okay, so 2 and 5. Okay, so we need to test these intervals. If I plug in a number between 0 and 2, is our velocity going to be positive or negative? Between 2 and 5, if we plug in a number, I don't know, like 3, is our velocity going to be positive or negative? Okay, and then after 5, if I plug in a number like 6, is our velocity going to be positive or negative? Okay, so let's analyze this. We know that our particle is stopped. Okay, it is motionless when there is no motion. Velocity is 0. So our particle is stopped at t equals 2 and t equals 5. And then I want to know moving right versus moving left. Okay, moving right. Our velocity is positive from 0 to 2 and 5 to infinity. So that is where we are moving right. Okay. Our velocity is negative from 2 to 5. So we're moving left from 2 to 5. I'll just bring you back to your unit 3 days, right? But what's nice about motion is I think our equations are fairly simple. Okay, for now. Our acceleration, let's go ahead and look at that. Acceleration. Callie, what would our acceleration equation be? Okay, so Callie, I like it because 2t minus 7, but just in case we have to evaluate anything, we should probably go to the very original one before we divided something out of it. Okay, so let's go to this one.
So 12t minus 12.
Okay, I know that we're still going to get that t minus 7 in there, but if I need the acceleration at like 2, I need to be able to plug it into this to get the actual value, okay? So we need to know where the acceleration is 0, which occurs at t equals 7, right? What?
It should be 12 doesn't factor out.
Oh my gosh.
6 factors out.
Here I was all excited, Callie. Okay.
No, 12 doesn't factor out.
Oh,
6 factors out.
6 factors out. We're still going to get the same thing as what Kelly said. I knew it was going to work out. 6t, 2t, minus 7. 7 halves, is that better?
Yeah.
We got there? Ugh. So our acceleration number line, to the left of 7 halves, our acceleration is positive or negative. What happens when you plug in something to the left? Okay, if we plug in 1, 2 minus 7 is negative. 7 halves to the right. like 4. It's positive. Okay? Now, acceleration alone, not a big deal. Acceleration and velocity together, big deal. So if I talk about slowing down versus speeding up, maybe we need to be there. Okay? So we really only care about from 0 on. Okay? 2 comes before 7/2. Do you agree? So if I'm reading this from left to right, we have an interval from 0 to 2. From 0 to 2, our velocity is positive, but our acceleration is negative. What does that mean? We're slowing down. So from 0 to 2, oh, I wrote it on the wrong thing. From 0 to 2, we're slowing down. Okay? Now, after 2, we're going to go from 2 until 7/2, because that's where the acceleration changes. From 2 until 7/2, our velocity is negative, hey, and so is our acceleration. So from 2 until 7/2, we would be speeding up. Then we would have from 7/2 until 5. Our velocity is negative, but acceleration positive, so we're slowing down. And then you can see that after 5, both are positive, so we're speeding up.
Wait, what is it from 7/2 to 5? Speed.
Slowing down because velocity is negative and acceleration is positive. Would you agree, Trevor? Okay. Okay, how do you feel? Good? Kind of nice, right? Last example, go ahead and write it down. We have about 7 minutes, we'll get through what we can. So we have t cubed minus 6t squared plus 9t minus 3. Okay, so the first thing I'm asking you to do, find the velocity and acceleration function. So write down s, find b and a, and then compare it to your neighbors to make sure you did your derivatives. Amy, what's your velocity function?
3t squared minus 12t plus 5.
Beautiful. Acceleration function, Michaela.
16.
How do you feel about those? Awesome. Part B, find the position of the particle at t equals 2 seconds. Find the position at t equals 2. Okay, April, what do we need to do?
Plug t equals 2 into the position function.
Sounds excellent. Okay, I'm asking for position at 2, plug 2 into the position function. So what, 8 minus 24 plus 18 minus 3, -1. Okay, let's let's talk about what that means. -1 position. One unit to the left of 1 unit to the left of the origin. So wherever you establish the origin to be, position is 0, then we are 1 unit to the left of that. Okay? Okay. Now, part C. What time the particle is stopped? I'm asking you to find what time the particle is stopped. Think about it for a moment. How would you find that? What time the particle is stopped? Okay. Henry, what do we need to do? Of which function? Very good. If I'm asking for stopped, okay, stopped deals with, speed, or velocity, I guess we should say, but it doesn't deal with position, it deals with velocity. So we need to know when our velocity function is 0. Okay. So this should happen at time is 1 and time is 3. Okay. And then we're not going to go through part D because I'd like to talk about your homework a little bit before we leave. But when we're determining speeding up and slowing down, in this scenario, you need to make a velocity number line, find the zeros of the acceleration, make an acceleration number line. Wasn't it really nice to have those number lines stacked on top of each other to see that? Okay, you want to do that every time you're talking about speeding up and slowing down. I'll give you a couple things here. First is your gold sheet. You'll see that our test is, like I said, Friday the 13th, the day after Calculus the Musical. We will have a quiz on Friday of next week. Your 3-day week is going to be rough, I know. Okay. But I want you to look at the homework I gave you. Notice, okay, so 1 through 10, vocabulary. But 11 through 14, I give you a velocity timetable. Okay? So you need to look at the different velocities to be able to tell, like when the particle would be switching directions. Okay? Velocity is negative at 0, but positive at 2. Something has to happen between time is 0 and 2. Okay? Now, this is a fairly long assignment, but you have a 5-day weekend. So I expect you to have this done for me. Have a wonderful weekend, juniors. Good luck on the ACT.